you took a sample from a population. Let's say one person takes a sample of a size greater than 30. And let's define a variable in that population. The variable we are going to define here probably is just the related to say the number of the level of defaults reported by a bank, say, over a period of say 30 days, say. Let's pick 30. So let those number of defaults be X. I'm going to take very simple numbers here. So suppose these defaults are grouped as 2 to 4, then 4 to 6, then 6 to 8, and then lastly, I'll sort out that 8 to 10. Whatever the variable is, it doesn't have to be the default, whatever it is, but you pick a sample of size 8 from a population, 6 to 8. And these are the frequency of occurrences of those default levels. So suppose this one here say about 4, and this one say are 15. This one is 20. That gives us, let's say more than that, doesn't matter. That is 39. That is 39. And say here 1. That gives us 40. Whatever it is. So I want you to write this. Just write them somewhere very quickly. So this is 40. Sigma F equals to 40. Then on this end, somebody else takes a sample. Let's just take the same values. It doesn't have to be the same values. 2 to 4. I'll just pick it from here anyway. Just pick these values here. Everything here. And I bring it here. Sorry. I'll bring it here. So this one say, let's reduce this number. Say this one is just 8. And this one is, say, that is 13, that is 8, 8, then this is 10. So this sigma F here is, say, whatever the number is, say, this is 9, this is 12, 22, 23. So sigma F is 23. This is a large sample. This is a small sample, say. So you have, I want to illustrate the two running concurrently. So this sigma F, that is sigma F. Sorry, I don't know why this is not working well. 4, oh good, I know why. So the objective here is to determine the confidence interval of the population mean based on these two samples. One sample is a large sample, therefore it's assumed normal. The other sample is a small sample, therefore it's assumed to be governed by a student T distribution. So I would want us to determine three confidence intervals, three of them. So the first one I would want us to develop is, say, 80% confidence interval. Say 80% CI, confidence interval for mu. And then I also want us to develop 80%, then say 90% confidence interval, and say 95% confidence interval. This will give us what we want to see for both cases. And we want CI for mu, the the population mean. It's 95%. Confidence interval. Now, last time I showed you how to derive a relationship for confidence interval. Nobody will expect you to derive a relationship for confidence interval. You're supposed to use the result of whatever we derived last time. So the same thing here will be here. The 80% for this, 90% for that, and 95% for that. So that you see, I want you to notice some features here in a minute as we get the figure. So let's start with 80%. The relationship for determining the confidence interval for mu. What was Ci for mu? What did we say if the variable is x? Somebody just mentioned Ci for mu. What is Ci for mu equal to? Anybody who remembers? Confidence for mu? Anyone? What is Ci for mu? Confidence interval for the mean. I'm waiting.
X bar plus minus.
So write that. Ci from Ci for mu equals to x bar plus or minus. That is for light sample. I'm here, I'm this side, eh?
Yeah.
So x bar plus minus
Z alpha over 2
alpha over 2
times sigma over square root of n.
Over the square root of n. That is it. It is x bar plus or minus, x bar plus or minus, let me just see where I have it somewhere here, plus or minus sigma over root n. And this is what we got, incidentally. We just bring it here. And that's all that's all you need to know. There's nothing else you need to know. That is all you need to know about the confidence interval. It is x bar plus or minus sigma over root n. So, and it's here. Let me just share this for you.
Excuse me, sir.
Yes.
I think there are some students who are waiting to be let into the class. They've just communicated on WhatsApp.
But this thing, it is free. It is free.
Oh, yeah, I don't know what they're saying.
Why are they waiting? And it is basically free. You can even see here. There's nobody here. Unless they are waiting in another class. Eh? You know, this also happens. Eh? Let me just confirm. Eh? There's nothing. There's nothing. They're in another class.
Okay, I'll just let them know.
Yeah, just tell them that too. So that is because I'm seeing Bilna here, Masharia only, but she's in. That is free. I removed it anyway. So what I'm saying here is that you pick your x bar is the mean, sigma is the standard deviation, n is the sample size. So this is actually what I'm saying. Let me just share this. The x bar, what we're talking about, x bar plus or minus. Let me just bring it here. So this is it. So these are two. The lower bound is x bar minus z alpha over 2 sigma over root n. The upper bound is plus. So that's why it is basically x bar plus or minus z alpha sigma over root n. That's the only thing you need to remember. There's nothing else. That's what we derived last time. Now, so we come back here. We come back here and now determine the upper bound and the lower bound of that confidence interval. So the first thing is to find X bar. X bar will be the sample mean, which we get by XF, using XF. No more, sorry, we first of all get X cap. You write X cap properly, yeah? X cap here is 2 plus 4 divided by 2 is 3. Then, of course, add the 2 all through, you'll get the other intervals. The other intervals you'll get. The other midpoints you'll get. Then I get my X cap, F times X cap. Let's just say X times X cap, which basically is this one here, is this frequency here, times this frequency here, which brings, and then we copy this everywhere. And then we sum. What's the sum of this? What's the sum of that? Sum is what? 140? What's the sum? It's here. 236. So our X bar equals to, right, that X bar, I'll bring it here. Let's get X bars here. Eh? This is our X bar. X bar equals to 236 over 40. What's 236 over 40? This divided by 40. So our X bar equals to 5.9. That is X bar. That's the X bar in that relationship of the confidence interval. Eh? Then we get our sigma. Sigma is estimated by S, the sample standard deviation. So it is basically normally X cap minus X bar, in this case is 5.9. Then you square this. Square this. And then multiply by F. Times F. You'll have gotten your squared deviations. Your squared deviations. And the squared deviations here we therefore are, it is this bracket, sorry, it is this one here, minus 5.9 squared bracket times F, another bracket here. That is the squared deviation. And then I come here. Then I also sum this. That is the sum of the squared deviation, which gives us the variance, sigma squared. Write that, please. Sigma squared equals to 79.6 divided by 40. That is sigma squared. Therefore, our sigma is equal to the square root of this. The square root of this, 0.5. So that is the standard. So all we need here is this. That's the first thing you need. Then you need this, which is our mean. And of course, we know n. What is n here? What is n here? What is n equal to? What is n equal to? 40. And you need this. Only. Those are the only things you need. Only thing you need. So, listen to the question I'm asking you. We have said, let me bring this thing, this side, so that you can see it clearly. Let me just see whether it can copy. I'll copy it. Let me just copy it anyway. Let me copy this, and you can see it clearly here. Remember, ours is not this way. I've copied everything. Ours is not this way. Ours is basically x bar plus or minus z alpha over 2 times sigma over root n. This one. So question I want to ask you. Let's deal with 80% confidence interval. 80%. So what is alpha of 80%? What is alpha? When the degree of confidence is 80. What is alpha if the level of confidence is 80%? To answer that question quickly, draw the normal curve. Just draw an empty normal curve. Normal curve, eh? Put the line of symmetry. The horizontal axis is Z. You've done that?
Yes.
Draw a vertical line to the left of 0 and to the right of 0, equidistant from 0, the midpoint, the center, eh? A vertical line, eh? Both sides of 0, eh? Equidistance, eh? From 0, eh? Then shade the middle region between those two vertical lines, eh? You done that, please? You done?
Yes.
Whatever you have shaded is our 80%, which is 0.8. That is the 80%. Remember what we talked about last time, eh? That is the 80%. 0. Yesterday, right, it's 0.8. So you have two unshaded areas on both sides of that shaded area. Is that true? One on the left, one on the right. Do you have that?
Yes.
What are their sizes?
It should be 2020.
Eh? 2020. So 0.2,
10 to make it 100.
No, is it 2020?
10,
10. So alpha is 0.2. Is that okay?
Yeah.
Alpha is 0.2. So draw an arrow to those unshaded area, label it as 0.1. The other side is 0.1. 0.1, 0.1. Done that?
Yes.
So the vertical line that separates the shaded and unshaded, where it meets the z-axis is Z 0.1. That is Z alpha over 2. Z 0.1. I wish I could share this. I wish I could share this so that you are seeing what I'm saying. Well, this is important. Let me just share something here. The normal curve, that you see what I'm talking about, clearly. See what I'm talking about clearly. I even think I have it somewhere here, I believe. Yeah, I do. I have it here.
A quick question.
Yes, please. Huh?
Have you uploaded these slides to Blackboard?
Everywhere. They're everywhere.
They're for week.
They may not be on the current week, but they are there. If they were not there, you would have made a lot of noise, I know. They are there. It means you are the one not seeing them. Look at this. Look at this. Are you seeing this one here? The normal curve,
Yes.
Yes.
Now this is what I was telling you to do, This is the first vertical line. Of course, this is the line of symmetry. So the first vertical line is here. The other one you draw this side, Here is what I'm telling you to point here with an arrow, indicate a 0.1, This side also the unshaded area 0.1, The shaded one in between is 0.8. Total is what? What's the total?
100.
What's the
One.
total?
1.
1. So this Z here is this, where is written Z here is what I'm saying. This is Z 0.1. You say Z 0.1, this side. And this side is what? If this is Z 0.1, the other one, this side will be what?
0.1.
0.1.
I get what I'm saying.
Negative 0.1.
Negative.
If this one is Z 0.1, so this side will be what? Here, down here.
0.1.
Negative.
I'm repeating my question. Are you getting what I'm saying? You know, you're thinking too quickly. Here, I'll start again. You are pointed here with an arrow that is 0.1. You have done that,
Yeah.
The other side also, there's an equivalent unshaded area, 0.1. Is that okay?
Yes.
In between is 0.8. Is that true?
Yes.
Total here, therefore, is 1. Of course, we know the area under the standardized normal curve is 1. This point down here at the symmetry is 0. Are we together, please?
Yes.
Now, this one is not Z, but Z 0.1. Is Z value corresponding to 0.1? So it is Z 0.1. Is that clear? Is that clear?
Yes.
So what is here? What is here? Here. Where I'm pointing.
0.9.
What have we plotted here? If this is 0, this is Z 0.1. So what is this one?
Minus 0.1.
Wait, minus what?
0.1.
Why?
Because you're moving to the left side.
But 0.1 is an area, is it? 0.1 is an area. 0.1 is this area, isn't it? Is this one?
On the right side of the
But also even yes, the area can never be negative. Can the area be negative?
No.
No. This area is also positive, isn't it?
Yes.
So what is here? 1 point. I'm not going to tell you what is here. The question I'm asking is very important. Very important, incidentally. And it's a very simple thing. You know why you're not getting it. I tell you why you're not getting it. Can I tell you why?
Why?
Because you are thinking of very big things outside this world. You know, very big things. The answer is here on earth. The answer is here with us. And the answer is very simple. Take simple things. What you think is wrong is the right answer. Well, I know what you think, what you are thinking. I've given you that this is 0. This is Z 0.1. So what is here?
0.9.
This country, I think COVID should clear it. We just go on the entire population.
0.1.
Let's start with how we started this course, this normal distribution. We said the normal distribution is symmetric. It is bell-shaped. The area to the left is equal to the area to the right. It has a line of symmetry. For the Z curve, the line of symmetry touches this line here at point 0, meaning that everything this side is negative. Everything this side is positive. If this area is 0.1 and this area is 0.1, it means that this Z here must be equal to the Z here. Is that true? So if this Z is Z 0.1, then this one must be negative Z 0.1. Is that true? Is that true? If this is 0, This is Z 0.1, and this is a line of symmetry, and this is the negative side. Then this one, if I put a mirror here, this one will land this side, on the negative side. So the value here is what now?
Minus 0.1.
But I've just given you the answer now. I've just given you the answer. Eh? See, I've just given you the answer. If this is Z 0.1, this is 0. So this is Z minus Z 0.1. That's what I just said, isn't it? This one, here, here. You know, if I put a mirror here, this one here will perfectly land onto some Z here, eh? On the negative side. Eh? So this Z here is negative Z 0.1. That's what I want you to write there. It is this Z here, incidentally. It is this one. Let me just, I also think we like what we see nicely. Yeah. Yeah. I'll go back to my PowerPoint, even I'll remove that. This is what I'm talking about, this one. Are you seeing negative Z alpha here, alpha over 2, eh? On the other side, it is positive. On the left side, it is what? Negative. Very important. In fact, if you can't appreciate the symmetric nature of the normal distribution curve, then we also have a problem in hypothesis testing. That symmetric property must be carried all through, including up to regression, actually, or up all the way, and other statistical techniques. So that's what I'm trying to bring out here. So therefore, all we need to do, so let me tell you what we have. This is what we have. I want you to write somewhere below there, N. Just write N there. Then somewhere there, write X bar. Just write X bar as a heading, eh? And then here, write here sigma. I'll share this if it's not shared, eh?
It's not shared.
It's not shared, I'll just share it now. Where is it? Where is it? Yeah, it's here. Good. So I want you to I want to create a table now. Let this be N. Let this be X bar. Here, write sigma, the sigma notation, sigma notation. And then here, I want you to write here Z alpha over 2. You write Z alpha over 2 properly. Z alpha over 2. Let me remove this from here now. Just write here, Z alpha over 2. Me, I'll write in words. Alpha divided by 2. Remember, it is a subscript. It's a subscript. And therefore, let's start with 80% first. 80%. CI. So these are the figures I'm picking. My N is 40. My X bar is here. That's my X bar. My sigma is here. My sigma, I calculate it is here. What I don't have is Z alpha over 2. But Z alpha over 2 for 80% is Z 0.1. Did you get that? Eh? You got that? Eh? The Z 0.1, eh?
Yes.
So it is here. I'll share this, eh? Z 0.1. Z 0.1. So Z 0.1, you read from the normal table. You go to your normal table, and so this is where we are. This is Z 0.1. We're not going to calculate anything. Just look at the table. This is Z 0.1 for 80%. Eh? So what to get Z 0.1, we want to get the area up to Z 0.1. The area to the left of Z 0.1. What is the area to the left of Z 0.1, please? What's the area to the left of of this one here? The area to the left, completely to the left. What's that area? What is the area? 0.9. 0.9. Because this is 0.1, so everything this side must be 0.9. So I go to my table and I look for 0.9 in the body of the table. Look for 0.9 here in the body of the table. 0.9 is which value of Z corresponds to 0.9 area in this body here? Which one? Give me an approximate value. The one closest to 0.9.
0.9015.
Which value of Z gives you that?
1.29. 1.29.
1.2. 1.29. Some people also pick 1.30. It doesn't matter. You see 1.30, eh?
Mm.
Yes.
Yeah.
So, but let's take 1.29, the one you have chosen, eh? So you have Z 0.1 here. I'll keep on sharing this, eh? You have Z 0.9 here. Here is 1.2 what? 29. That's what you have found. Is that it? Is that okay, please?
Yes.
So we know how to get this. 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 So now we go to now, then I add another column now. Lower confidence limit. And then upper confidence limit. I'm just creating a table for you. So what's the lower confidence limit? What was it? Tell me what was it? It was X bar, remember, minus. When you subtract, it is lower. When you add, it is up, eh? Because that relationship I've given you, eh? So it will be X bar. Where is that? Did I remove that thing anyway? You see that? Good. It is this one. E. X bar. It is here. X bar minus Z alpha over 2. What is Z alpha over 2 here? What is Z alpha over 2 here?
1.29.
1.29. So this one here is basically, I'm using brackets, eh? Is basically X bar. What is X bar? X bar is here. Minus Z alpha over 2. What's that alpha over 2? It is this one here. Is that okay? Then, because we put a bracket here because we are going to do something, sigma. But I think we need to get root n, eh? Root n will be okay for you. But we can do it here together. So it is minus this divided by what? Minus, it is minus Z alpha, which is this one here, times what? What is sigma? What is sigma?
1.4.
Sigma is here, isn't it?
Yeah.
Divided by, there's so many brackets here which will confuse you, eh? Because I'm using Excel, eh? I want to get the square root of n first, eh? Let me just get the square root of n here, eh? So that the square root of n also becomes a constant, eh? So just say root n. Root n. Root n here. Can put it anywhere anyway. What's the square root of n here? It is this, the square root, 0.5. That's the square root of n, eh? Which is 0.3, 6 point that, eh? 6 point that. So I'll come here now, the lower limit. Lower limit is X bar minus this times that. So I'll come here, bracket, X bar is here, minus Z alpha over 2. Where is Z alpha over 2? It is this one. Times what? Sigma. Where is sigma? Where is sigma?
1.1.
Sigma is that one, eh? Divided by what? That one. And we are done. That's fine. That's fine. So this one is when we add, when we subtract, minus this, minus this, minus this. That's what I've calculated in Excel, eh? Then I copy, then this one here, the same thing, this one. This one here. This one. But I bring it here. So what, I'll just edit it. So it is X bar. where's X bar? This one here. Minus Z alpha over 2. Where's Z alpha over 2? It is this one here. That one there. Eh? Times what? Times sigma. Where is sigma? This one here. Divide by what? Divide by what? That one there. But now it is not minus, but a what? A plus. No, come on, please. Suppose we are plus, eh?
Sir, you didn't change
Formula is
F13.
wrong. Yeah, your formula is wrong.
Didn't
Yes.
change what?
At the top, you've done F13 by
I want to. That's what I want to
It
check.
should be D13.
That's what I want
D13,
to
yeah.
check, eh? Also this
D13.
E13. And this one plus, eh?
Yeah, plus.
Adding. And this one, is this fine? That is Z alpha over 2,
Yes.
which is this one, eh?
Yeah.
And this one is sigma. Sigma, eh?
E13.
E13. And then this one divided by root n. Where's root n?
C.
E. That is it. So 5.6 to 6.18. Note that, eh? So it means that based on this sample, you don't know the mean. You will be 80% sure that you will get the population mean between 5.6 and 6 point what? 6 point what? 6.2. Anywhere between those two. That's the confidence interval for the mean. Then now, I go to 90%. Please, if you didn't get it there, get it here. 90% CI. 90% CI, this will not change. N is the same. Eh? N remains the same. 40. Let me just make it 40, because it's 40 anyway. N remains the same. The square root of N remains the same. X bar does not change. Sigma, X bar does, where is X bar? 5.9, eh? Let's say 5.9. Let's not make it a formula. That one does not change. It's the same data set, eh? This one here, sigma. Where is sigma? Is this one, eh? I also don't want it to change. So I just copy this, eh? And then paste special here. It remains a constant, eh? And then I copy. This one also does not change. Well, the only thing that changes is this one. Now, I don't want to even now, just imagine the normal curve. This was 80%, eh? We got Z 0.1. How about 90%? How about 90%? You're going to get Z from the normal table.
0.5. 0.05, sorry. 0.05.
0.05. So you go to your normal table here. 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 This one here. Sorry. If in between, we drew some two lines here. This one here is 90%, in between 0.9. So it means outside is 0.1. So it means that half of that is 0.05, this side is 0.05. So this will be Z 0.05. So which area is to the left of Z 0.05? Which area is to the left of this line here? If this 0.05.
Negative 0.05.
Can an area ever be negative under the sun? Area.
Oh, area.
If this is 0.05, therefore this is Z 0.05, which is this area?
99.95.
What is this area? If this area is 0.05, what is this area? This one.
99.95.
0.95.
Okay. 0.95. So come and look for 0.95 here. Which Z value corresponds to 0.95? It's a standard value, known. Which Z value corresponds to 0.95?
1.65.
1.64.
1.65. That is the value. Always known. 1.64. So this is 1.64. 5 anyway. Then I don't have to do anything. If this was Excel, I just copy this one downwards. And that is my confidence interval. That is my confidence interval.
Please share your screen, Mwalimu.
Ule amefence huku ndio nataka piga ikiwa karibu.
So this was 80%.
Kwa screen yote.
This is 90%. Now we go to 95%. 95% CI. Again, this will never change. They will never change. They are the same. Standard deviation. All those ones remain the same. This is 95%. 95% CI. What will change is here. So which area are we going to look for in our table? Normal table for 95%. I'm not going to show that diagram again. Which area are we going to look for in our table for 95%?
$2.5.
Which area are we going to look for in the normal table at 95%?
0.975.
0.975. So come here, look for 0.975. It corresponds to what? It's also a known figure. 0.975 corresponds, which Z value gives 0.975? Which Z value gives you an area of 0.975? Have I shared the normal table? Is it shared?
1.96.
Eh?
No.
Which area corresponds to 0.95? Sharing it. Which area? Which Z value gives you an area of 0.975?
1.96.
1.96. Another standard value known. And I'll share it again. Come back here. So this figure here, this one. I hope it's shared. Excel is shared. This one is 1.96. This one here, 1.96. That is it. Then I copy this downwards. That is it. That is the confidence interval, 95% confidence interval.
Your N is at 41.
Just change it to 40.
It will affect the numbers.
See that? Are you seeing those things? Now, what has happened? What is the effect of, write that. What is the effect of the confidence level? What is the effect of the confidence level on the size of the confidence interval. What is the effect of the confidence level on the size of the confidence interval, or the width of the confidence interval? This is the confidence level, these ones here. Degree of confidence, DF, just call it degree of confidence. Or just call it, yeah, degree of confidence doesn't matter, which may confuse with degrees of freedom. Let's call it confidence level. It may confuse you with the degrees of freedom. This is now, to get the width here, let's get the width of this confidence level intervals. That's the size. The width here is this minus this. What is the width there? If you can see it clearly. What's the width here if you can see it clearly?
0.5.
0.575.
575.
Look at the rest. What has happened? What happens to the width of the confidence interval as the confidence, the width as the confidence level increases?
It also increases.
It increases. It increases. It increases. That the larger the confidence level, the higher, the larger the confidence level, the wider the width of the confidence interval. Practically, this means that the higher the confidence level, the higher the likelihood. The higher the confidence level, the higher the likelihood of finding the population mean, within the given interval. Within the given interval. And that's a very important interpretation for practice. That it's better for you, it would be better for you to have higher confidence levels as opposed to lower ones. Lower ones like 80, 70. Better ones are high ones. 99, in fact, 99% will even be the best. 100% will be perfect, but you can never get 100%. So that is the confidence interval for large samples. Now, if you didn't get it here, now let's come here. The only difference here is that here we are going to use a student T as opposed to the normal distribution. So the best thing is just to copy this one here. Copy. Okay, let me just copy this. I copy everything because we already have it. We already have it anyway. Change this. And I come here. Just copy all this data set. This data set here. Then we change these things. What was the frequency here? What was the frequency? Somebody please. What's the frequency for the small one? What's this frequency here?
4.
4. Then
8.
8. Then
10.
10.
Then 1.
1. Then 1, eh?
Yeah.
Giving us a total of what? Total of what here?
23.
Total of
23.
23. Let's just put 23 here. And then, so X cap remains the same, isn't it? So this one is fine. No, that's fine. No. That is, yeah, that's it. This okay, that's okay, that's okay. Yeah, that is 40, that is 70, that is fine. X bar therefore is this divided by that, which gives you that. 5.6 5.7, eh? Then this minus 5.7, let's just make this 5.7, like that. Then I come here minus 5.7, gives us that. Then I come down, copy this everywhere, here. Then sum them, we get that, eh? And then we get the square root of this. So divide this by that, by 23, we get that. Then we get the standard deviation, the square root of that, we get the standard deviation, which gives us this. Those ones, the only thing that changes there is the sample size. Then I come here now. Here, this one is now 23. We agree? 23. 23. Then this is the square root of 23. Square root of 23? That's it. Then this one here is x bar. What is x bar? 5.7. 5.7. Sigma changes. Where's sigma? Sigma is here. Sigma is there. And I copy this everywhere. Then now, this is now not Z alpha, but what? Z alpha over 2, but what? For the small sample, we said it be what? Is it Z alpha over 2? Z alpha over 2. Which distributions govern small samples?
T distribution.
T distribution. So this is now T alpha over 2. T alpha over 2. T alpha over 2. At a given, at n minus 1 degrees of freedom. At n minus 1 degrees of freedom. That I mentioned last time. At n minus 1 degrees of freedom. So that is that heading, T alpha over 2, comma, n minus 1. You don't have to write degrees of freedom. It's understood that when you write T alpha over 2, comma, n minus 1, we know you are talking about degrees of freedom. So now you don't use the Z table. Use the T table. Those other things will remain the same. It will be T 0.1, T 0.05, and T 0.025. So let's start with the 80%. I want to show you how to get T 0.1 at n minus 1 degrees of freedom. What is n? What is n in this sample? What's n?
23.
So what's n minus 1?
22.
22. So you go to the T table, and look for, and remember this, and you know you're looking at both sides of the, so this is Z, eh? This is Z, I believe. Just a minute, I'll get to the T table just now. I want to get the T table first. T table. Yeah. So I'll come with the T table here. I'm sharing it. Please just imagine the normal curve. That's what always should be in your mind, the shape. T table. Remember, if it was normal, we would have had a curve. We would have had whatever diagram up here, curve, a bell-shaped curve here. That is the same shape at T. So 80% is still divided as 80%, even on the T table. On the left-hand side, we have 0.1. On the right-hand side, we have 0.1. In the middle, we have 0.8. So you can only, because those 0.1 and 0.1 are on both sides of Z, of 0. On both sides of 0. 0.1 to the left, 0.1 to the right. You are talking about two tails. Two tails. Two tails. So two tails means that, and listen to this, please. two tail at 0.1 is not the same. Let me come back here. Let me just a minute, just so that I clarify this clearly using the normal curve. Just curve, normal curve, because it's the same curve for T. So that one is picked. So this is the curve. Let me share it. I'll just share the negative side. Doesn't matter. All we want is the curve. The curve. On this curve here, you drew a line down here. It's the same shape as of T. You also drew another line here. This side was 0.1. This side was 0.1. Remember, these are two tails. Two tails. So the first tail this side is 0.1. This tail this side is 0.1. What does this mean in terms of what of T? You go the other side of T, you're going to look at two tail 0.1. Here, this is 0.1, this is 0.1. That's one way of looking at it. So what is two tail 0.1? What's the total of two tail 0.1? What's the total of 0.1 plus 0.1? What is 0.1 plus 0.1?
0.2.
0.2. Remember, for 80%, we're dealing with 0.2, isn't it? Isn't it? So all you need to do is this. You are not going to look at this. Let me share this for you. Let me share this for you. Let me share this for you just now. And listen very clearly. For the Z, you simply went to the table and looked for Z 0.1. You did, isn't it? Isn't it? For T, now this is it. For T, now you'd come here and look for two tail 0.2, because it was 0.2. It's 0.2 you are dividing into two. One 0.1, one 0.1. So you look at this lower row here, this one, this lower row here, this one. If you're looking at confidence intervals. So two tail 0.1, 0.2 means 0.1 on one side, 0.1 on the other side. So I come and look at two tail 0.2, which you can see is the same as this anyway. So you come here, come along this line here up to n-1 degrees of freedom. How many degrees of freedom are we dealing with here? How many have we said?
22.
22. I come down here all the way up to 22. This is my value. Where is it? It is what? 1 point what? 1 point what?
321.
1.21. This is what you pick. This one is what you pick. And we take to our Excel. Just notice somewhere there. Notice, just notice, we'll go back there. We'll go back there. So this is that is 80% confidence interval under T. How about 90%? 90%? What are we going to look at here? For 90%, what are we going to look at? Two tail?
0.1.
0.1. So just come here. Where is it? Here. Where we are? All the way up to 22. Which value are you talking about there?
1.717.
Write it somewhere. You done that? And how about 95%? What are we going to look for? Two tail?
0.05.
0.05 is the next one here anyway, which is 2.07, 2.074. Are we together, please? Then I go this side now. Let's go back to our Excel. Our Excel is here. So give me the 80%. What was it about? What is it equal to?
1.321.
1.321. Fine? And the other one?
1.717.
17. And the other one?
2.074.
1 point?
2.074.
2.074. That's it. Is that okay? You can see that what our earlier conclusion still stands. That the higher the confidence interval, the wider the width, isn't it? That's what we knew, isn't it? But now, now we have introduced something else. The size of n on the width. What is the effect of the size of n on the width of the interval? To get to do that, you compare 80 and 80, 90 and 90, 95 and 95. So what is the what is the effect of the size of the width on the interval? The size of the size of the sample size on the width on the interval. The size of n on the interval. What's the effect? Does it increase it or it decreases it?
It increases.
It increases. It increases. So also note that as the sample size increases, the width of the interval also goes up. And you can see it is going up. You compare these two, compare this and that, this and this one here, this and this one, because you can only compare similar confidence levels with respect to this. Is that okay, please? So
Yes.
quick, very quickly. And this one you do very quickly, very quickly, very quickly. Determine the 97.3%, the 97.3% confidence interval for the mean with respect to the following data set. This one is very easy. Data set. I'll just give you a very simple case, very simple case, very simple. That is 7 to what? 7 to 9. Have I shared the sheet anyway? Are you seeing the sheet there? I believe you are. So let's come here. Let's just make this figure here, say 5. This one here, 10. So let it be 20. That is 25. 25 plus 5 is 30. So I want you to determine 97.3% CI, confidence interval for the mean for that data set. That data set there. Give you 5 minutes or 10. You copied. I want to share for you the normal table, eh? Do I share? Copied?
Copied.
Good. So I'll share with you a normal table. That's the normal table. You know, it will be somewhere there. Now, whenever you open SPSS, this is what you see. And I'll make your life easier. There is no difference between, in terms of manipulation. what you do with SPSS and what you do with any other Microsoft Office. There's no difference. The current versions of SPSS are basically similar to in terms of manipulation as Microsoft Office, Word, Excel, PowerPoint, name them, the way you manipulate them. So this is what you will see. But of course, you'll see different things here. The first thing you'll see here is if you want to open a data set. In Word, you open a document. In Excel, you open a workbook or a sheet. In PowerPoint, you open a PowerPoint document, etc., etc. Here, you can open a new data set. A new data set. And for you, forget about new data set based query. Your concentration here. You deal with the data sets. This is what you will see. But if you add if you add all the files, just like in Word, in Excel, in PowerPoint, you'll get your files all the way here. But you can also open them from the normal file open scenario. But these are the most recent files. And in Word, there's a maximum number of recent files that can be listed. Excel the same, PowerPoint the same. Here also the same way. So this is what you will see. Now, we don't have any other file we have opened. So we'll open a new data set. So simply click here and then open your new data set. Sorry. Your new data set. And that is it. I'll share it if it's not shared. I just clicked new and this is what I got. That's it. So if you look at this, which MS Office does it look like? Which one does it look like? SPSS.
Excel.
Excel.
Looks like Excel.
These days, the latest versions of SPSS are Excel. You know, the older days, they were not compatible. They were all spreadsheets like. But the current versions of SPSS are nothing but Excel worksheets. But here we don't have many worksheets. Excel, you can have any number of rows. SPSS also, you can have any number of rows. You add them, you insert them. The same thing you do in Excel is what you do here. If I want to insert a row, I insert a row. If I want to delete a row, the same way. Now in SPSS, rows are called cases. A case is a respondent, say, respondent number 1, number 2, number 3, number 4, number 5, all the way, whatever your sample size. If you had 100 respondents, you'll have 100 rows. In fact, you'll probably have 101. If the first row is probably the respondent ID, like your ID, your student ID, you want to have it there. Or just the label, you label your questionnaire as number 1 up to 100. You say that is the respondent ID, because respondents, they will give their names. So these are the cases, the rows. Just again, like SPSS, like Excel, SPSS has columns. And you have got infinite number of columns. You can add them the way you can insert columns, you can delete columns, the same way. The same way. No difference. And these are cells. These are cells. Just like in Excel, you also have cells in SPSS. Now, Excel has worksheets. Worksheet 1, sheet 2, sheet 3, which you can add sheets as you wish and delete them as you wish. Manipulate sheets as you wish. SPSS only has 2 pages. The first page is called the data view. This is where you enter data. The other page is where you define your variables. Variables are defined in the variable view. Then you enter your data. Whichever you do, it doesn't matter which one you do first. It doesn't matter. But when you are starting, normally it's better to start from here. If you're experienced, you can start from anywhere. People just start from here and then come and do this, or start here and come and do this. It doesn't matter. Whichever start, you can start with any of the two, any of the two. Are we clear there, please? We are clear. But where are you today? Actually, I'm not even seeing you here.
Yes.
I don't know what you did.
We are clear.
I want to see whether you are there. Now, so these ones are very important. These are very important. This one, manipulation. I'm still on this first water cover here. Now, let's come to data view. This is the data view I've clicked. You can see the data, each column is labeled var. These are variable, these are default variable names. Default variable names. So if I came this side and I've had a variable here called gender as my first variable, I type gender here. Now gender will replace this one. If I came here and I type age here, the second one, age will now replace this one. So as you change this one, as you type your variables names here, these ones here now will correspond to the appropriate variable names. You can edit them the way you edit in Excel. You can enlarge columns. These columns you can enlarge. The same thing you do in Excel, you can manipulate them like this. But you can also define them, just like you define them in Excel, column width, using the menu systems. So this is important. Then I go up here. Here, menu. The first, just like in Microsoft Office, you have got file. The other side, in Microsoft Office, what do you use file for? Tell me the things you use file for. Just tell me. The file menu, what do you use it for?
Open, save.
Open a file.
Opening, browsing a file.
Pardon?
Browsing a file.
To use
Close, open.
the correct terms in Word, you know, the correct ones. You normally use Word, isn't it? You open a file, isn't it? You also open a new file. You can open new, can't you?
Yes.
What has to do with the file? You use
Save.
save.
Print.
Save as, isn't it?
And print.
Print.
Export.
Export.
Import.
Import. Let me tell you this, and please just listen me clearly. Those things, those items you use in Word, those are the ones you deal with here. Don't come here and start asking me. Let me tell you, you open a new file, isn't it? In Word, Here, you open data. You are getting this one? A new data, You open an existing file. Here, you open a new data, existing data. You import a file. Here, you import from where? In fact, you'll always be importing from Excel. Excel, this one, here. You know, if you have learned these others, that's when you go here. You know, don't ask me what are these, how do you import here? What are you going to use it for? I'll ask you, You import here. That's where your life is, You close a file there, you close a file here. You save a file here, you save a file there. You save us here. You export. You don't forget about this, forget about anything else you're not used to in Word, Deal with all the things you're used to in MS Office for this course. We are done with the file. Is that clear, please? That's clear, my brothers and sisters.
Yes.
Good. Let's come here. Edit. Don't ask me things that what you come down here. Where is it? Let me see what you do with edit. You undo, you redo. Is it? You undo, redo, cut, copy. Copy, any copy, paste variable. You know, there you can paste a column. Here you can paste a variable. You can paste a row. Here you can. I mean, what was it? Paste variable names like gender. You can also insert, just like you can insert a variable, a column in Excel. you can insert a variable column. These vars here. Just like you can insert rows in Excel, you can insert cases here. Anything you see here that you are not used to in your lifetime, forget about them. They are not going to change your life in data analysis. We are done with edit, isn't it? We are done? Is that easy? I come here.
Yes.
View. View here, you do nothing. Forget about this one. Forget about this one. You not, I can tell you, I don't come here myself. The key ones now come here. There. Data. You deal with data here, isn't it? And I tell you what you deal with here only. Only. Here. Rarely. At this point, you define where variable properties, you'll have defined them in variable view. You'll have defined them. Set measurement level. You know what the measurement levels we are talking about? The four, The four. You can do them here, but I'll show you how to do them well. Transpose. You can transpose a file in Excel and bring it here. There's no problem. Just changing rows and columns, interchanging them. So again, here, data here, for now, it will not impact heavily on your analysis. What will impact heavily on your analysis is this, and this. Transformation. And under transformation, you only deal here mostly with three things. The first one is to compute a variable. The other one is record variables. Record into the same variable, record into the different variable. These three, this, and that are key. And then this one. Sometimes you collect data, then you don't get some data values, then you come back. Now you want to insert that data value amongst in a sea of data. You don't have to look for that data. You simply go find and replace. The way you do it in Excel, you find and replace here using replace missing values. So this, that are key. I'm just on menu items. And then your life is here now. This is where statistics is now. This is now data analysis, both descriptive, inferential, and regression analysis happens here. So what you use here are this, that, the first three, correlation, regression, and that's it. You are done. You are done. These others are for future use. Here, there, and there. The five are key. That's where you analyze data from in your course. That's where your syllabus is. And then lastly, here. Drawing graphs. In the olden days, we used to draw graphs not using this. Your life is so easy these days that you don't have to draw a graph. You have been given a chart builder. For you to build a chart, you simply select the chart you want to build. This SPSS will build it for you. By all you need to do is to define the variables that you want to build a chart for. So here, this is what you use. This one. Forget about this one. This is the best for you. Chart builder. And that's basically what we are going to deal with. Now, so this is it. Then below here, we have got just like in Excel, in Word, we have shortcuts. You know the shortcuts in Excel, they are the same ones here. Print is here. You know, all these things are here, you know, here. And do redo is here. Those ones, among other things. So basically, that is SPSS sheet. So I want to give you a very comprehensive overview of how to enter data in Excel. And to do that, I told you that you're going to do a one group assignment on Excel, and it is only one. This one is based on the data I gave you earlier. Remember the data I gave you earlier? The data in your the one you did group work on. Remember that data set where you had got you had what? You had where was it? Where you had I don't know what it was. What was called? It was called sales something. You remember the sales data?
Yes.
You remember the sales data? The sales data.
Yes.
I want to open it just now, but it's not the one. The sales data is a good data set, which can enable you to, let me just see, I don't know where it was. I want it in Word. I want it in Word, Sales data. It will be better, it's the best one because I know the way the data is crafted is not always how you collect data. That's why I want to use it, so that you learn two things at the same time. That is, I got it, yes. Sales data, so it's not opening. That data set had the following items. Good. Yes, and this one was a different thing. The sales data was, but I can use this. Let me use this. I want to use one here, which probably would be, let me just share this. Let me share this. This is just another sample data set. It's not for you anyway, but it's the same, it's a sample data set. Are you seeing what I've shared there?
Yes.
Good. This data set was intended to an investor wanted to determine the factors that affect salary levels. That could affect salary levels in Kenya. Your group has been commissioned to undertake a study using a sample of 534 respondents. In fact, even if you're the million, they'll ask you something randomly selected from the key sectors of the economy. You decide to undertake your study using data on 11 variables. So the variables are properly defined. You define the variables yourself. You can call them X1, X2 up to X11. It doesn't matter. Or just give them variable names. This one we gave variable names, and the variable names are here. Education all the way to marital status. Those are the factors that affect salary level in that study. And these variables are described here. Number of years of education is education. Because you can measure education in two ways, either by the number of years of education or by level of education. No education, primary, secondary, university, blah, blah, blah. Or you can just say, I took 10 years in school. That's a number of years. Or region where you come from, Nairobi or elsewhere. Sex, male or female. Experience, number of years of experience. Union, whether you're a member of the union or not. Age of the respondent. Religion, your religious affiliation. Occupation, your occupations are here. Then marital status is that. So you want to analyze this data. This is actually a regression problem and hypothesis testing problem. You want to analyze this problem, the salary, how these factors affect salary. You can decide later on, you see, to build a regression model to predict salaries, or check how these factors affect salary, hypothetically affect salary. So if we are to use SPSS, not if you are to use, you are using SPSS to analyze this data. You have collected your data from 534 respondents. It means you gave them a questionnaire, say, and you collected data from all of them. All of them. Here, Then now you want this, and you want to analyze this data. This data could have been entered this way. Are you seeing forget about this is number of years? We know number of years in education is quantitative variable. Therefore, it is a scale. We know region is non-quantitative, is qualitative. Therefore, it is nominal. Gender is nominal. Experience is scale. Union membership is nominal. Salary is scale. Age is scale. Religion nominal. Occupation nominal. Sector nominal. Marital status nominal. So we only have two types of level of measurements here: scale or nominal. There's no ordinal here because there's no variable which is characterized by order. That must always be at the back of your mind before you start analyzing data. Then now we want to use SPSS to analyze this data to advise that investor. So what do you do then? You can decide. Let me tell you, I'm asking a very simple question. This data, you send somebody out there to collect it for you. The respondent, the numerator came back. And instead of writing male, female, you know, this is male, say. I don't know, male was what? Male is what here? Male is 0, isn't it? Male is 0, eh? This one could have read male, female, sorry, female, male, male in words. This one could also have read something else. Where is that? Where are the things? Member and member, union membership. Member and member, member and member, member and member. If that is the way your enumerator entered your data in words, you must code them. Code them by saying let 1 be equal to female, 0 be equal to male. Let 1 be equal to union membership, 0 be equal to non-member. For those nominals, before you start entering your data. Because those male, female will be derived. That's not a problem. That's not a problem. So you have 2 ways of entering this data. Actually 3 ways. 3 ways. Let me start with 3 ways. The first way is basically to go to SPSS. Go to your SPSS. Remember, there are 11 variables, 534 respondents. So how many data items are you going to enter? I may ask you, how many are you going to enter? Somebody? How many are you going to enter?
534.
Data items are you going to enter? Data items.
11.
You have 11 variables, 534 respondents. How many items are you going to key in?
534.
Only.
5874.
5,874. Because you must key in data for all these variables, don't you? And the respondents, don't you?
Yes.
So you are going to enter 5,800, over 5,800. Do you have that time? But if you don't know how to enter, you go that path. That's not a problem. Because people do that anyway. People do that. That is one way. Forget about that way. Because data these days is collected using Survey Monkey, which of course has an Excel background. So you see that data is collected in Excel. So you need to always take your data from Excel and take it to SPSS by using 2 methods. The first method is to import that data after cleaning it. Cleaning it means changing those words. If that was male, female, change to 1001, 1001 for nominals. Export or import from Excel. That is one way. The other way, if your data has been cleaned this way, do what you do in Excel, copy and paste. Copy and paste. That's the quickest data entry. Now, before you copy and paste, now we must define these things first, because these are not this is not data. These are variables. These are variables. You enter them in Excel. Let me go to in SPSS. So I come back to SPSS here. Here. I define my 11 variables in SPSS. I define them here. Variable view here. Here. The first variable in that data set, let me just go the manual way first. I'll tell you what you need to be doing. I'll just give you what that variable was. The first variable there was education. Education. So I simply come here and type education. I don't have to type the entire thing. I can just say A-D-U-C. I don't have to type everything. I can even call it X1. It doesn't matter. I can call it whatever I want. Just call it ADUC. Because there's no need typing long things here when you know it is meaningless. It will be meaningless eventually. This is an identifier of a variable. A variable name is basically an identifier. Meaning is given elsewhere. So this education here were number of years in education. So this number of years in education is a quantitative data, and hence it can never be. You come and click here, type. There are only two types you need here, either numeric or non-numeric. Numeric is always here as a default. If a variable is not numeric, then it is non-numeric, it is qualitative. All qualitative variables are string. So if this were not numeric, I would click here and get my string. But this is numeric, I leave it that way, and I do okay. Width here, just leave 8 as a default, because you can always manipulate width. Manipulate width of the data if the data is wider than 8. Number 2, decimal. You only place decimal if you know that your data values have decimal points, because you are the one who has collected data anyway. My data set has no decimal, so I reduce it to 0, or I can increase it to 10. I can even type there like that. Then a label. This is what gives meaning to this thing here, this one. I could just call this one, I could just call it X1. But whatever I put here will be in the output eventually. So this one here, I know it was number of years of education. I go to where it was typed in Word. It is in Word somewhere. I go and get it in Word, and I simply come here, and where is it? Number of years of education. I'm in Word, don't worry. I just copy, I don't have to type, I copy from Word, wherever it is. Even if it's for an Excel, I copy number of years of education. I'll just come here, Excel, and I paste it here. Here. Sorry. It's waiting for it's pasting. I paste the normal way. Paste normal way. It's here. Number of years of education. You can even copy this from your questionnaire and paste it here. Then values. Values. Please, I hope you're noting this. Values. Value is only important for non-numeric variables like gender, a union membership. The codes, those are the values, those codes. 1 is equal to male, 2 is equal to female, whatever. So this one is meaningless for numeric. Missing. If you know, and this is always the truth in reality, that you will never get all the data values. Some people will not give you, will not respond. I can tell you for a fact, some will not respond. So what happens is, what do you put when somebody does not respond? In the olden days, we used to ignore any variable with missing values. But these days, SPSS will analyze data. Statistics allows you to analyze data with the missing values. And you should only have one indicator of missing values. I would say that anytime I see a data set, an item, without a response, I type a figure. I choose my own figure, you choose your own. The figure you choose should not have any chance of appearing in your data. So you can say, I choose a figure like 9999. Whatever figure you choose. Can it be 9? If your data set numbers were lower than 90, just say 100. If they were lower than 200, just say 250. Anytime you see a data type missing, type 250. SPSS will read that as a missing value. So here I'll just put 999, say, because I know there's none. So every time nobody responds, even on gender, on anything, I'll put 999. Column, again, leave as a default. It will come to pass. Right alignment is basically beauty. You know, like in Excel, you left align this side, right align center. This one here, very important now. This one is dependent on the type here. So you see this numeric, and numeric must be scale. If this was nominal, it will be nominal. If it was ordinal, it will be ordinal. So you only have 3 things here. If it is interval like 10 to 20, that is still nominal. So you have scale, ordinal, and nominal. Because this is numeric, this is scale, and that is properly defined. Input, forget. Now I've defined my first variable. Now come this side. You can see it here, education. Properly defined. Are we together, please? We are together?
Yes.
Good.
Yes.
Now, so you can enter all your variables, all of them. But you don't have to do that really, because all I would do is to come here. I'll just give you an example. Come here and pick this variable here. I'll just pick this one. Let's say, let's pick everything, but you see some error, I know why. Come here. These variables are how many? They are 1, 2, 3. They're there. They are in Word, eh? I bring them to Word, to Excel, because Excel is the one compatible with SPSS. Eh? Instead, those are variables, eh? No, I don't. No, sorry. I'll bring Excel. Eh? I've pasted those variables from the Word table to Excel. To Excel, eh? It's here. See that? I don't want to keep on typing those things the other side. Eh? So I ask you, just compare this. Look at these variable names. They are in column. Are they in column?
Yes.
In the column here. Eh? But however, in SPSS, are they in columns? Are they in columns? No. I'll show you.
No, they're in rows.
They're in rows, isn't it?
Yeah.
They're in rows. They're here. Here, they appear like this. They appear like this. Are you seeing this?
Yes.
So
Yes.
what do I do to copy and paste them here? What do I do in Excel?
You transpose.
Transpose. So you go to Excel, where we were. So you pick this one here. Take this, and then I just transpose, paste special. And then, so that's a paste, sorry. Then I transpose, I come here. That is now in column form, which is aligned to the expectation in SPSS. This one here is that form. See that? Then now you can copy these things. You can copy them. Transposed. You can copy them and take them to your SPSS, where they start from here. They start from here. Here. Then paste them. Paste. The others, because of I think that they have commas, eh? You know, you have to check, make sure that your Excel variables have nothing. But you have seen what has happened. It has pasted how many? How many? 2. Never see replace. Just go and check the formatting on those other variables. They will copy. But it's that's just showing you what this is all about. This one here. You're supposed to have 11 variables. 11 of them. Even if you came this side, where are they? Come here. Union membership. You know, probably have some commas here, some errors anyway. Some errors somewhere. To confirm, but it's not like gist here. The other one is experience, and that's the one which had a problem actually. So just to type it, I'll type it here, experience, rather than going to deal with the statics that side. I just come here and I type here my experience. Here, experience. I don't have to type the word experience. Just type exp here, because that's meaningless. The other variable here I can tell you for a fact was, I'll read for you the names, very, very easy. The other one is experience, union salary age, union salary age, union salary age. So write the union salary age and then religion. So union salary, I also don't have to type uni, just type uni. Then SAL. Then S, that is the salary. Then age. Then which other one? The other one here is very quickly. Union salary age, religion occupation sector. Religion occupation sector. Just come here. Here, just type religion occup sector. And then marital status. Marital status. Then now you know what it means. This one here, religious affiliation. You just go and copy that side, bring it here. Religious affiliation. Affiliation. This one you can spell check. Gender of the respondents. Then here, number of years of work. Number of years of work. Here, union membership. This is what's meaningful. This is what I'm typing here. Here, salary levels. Levels. Here, age of respondent. Respondent. Here, what was it? Religion. Religious. No. This is a religious affiliation. That's the affiliation actually. The other one is not. This one here is region. Where you're working. Then the occupation of the respondent. Here, sector. And here, marital status. Sorry. And here, marital status. Status. Is that okay? If I forgot a variable here, because these variables must be aligned with the way the data is entered, then I would have just come here to insert. Insert what? A variable. Then I just edit this, change this, type the name here. But we don't need to, I undo. Just undo that. Then you now define everything else. Of course, region can never be numeric. It is a string. Sex can never be numeric. It is a string. This one, because there's nothing here. This one, I thought I deleted it. So just clear it. Then also this number of years, of course, is numeric. The number of years. Union membership is a string. That's the qualitative variables. A salary, of course, is numeric. Age is numeric. Religious affiliation is a string. It's a string. And then, of course, occupation is a string. Then a sector is a string. And then marital status is also a string. And then now the rest now. Of course, you know, strings will have 0 decimal places by default because they are non-numeric. Even these ones, I know our data set has nothing like decimal. Just change them to 0, 0. It doesn't matter. 0, 0. You can also type here 0, you know, among other things. Then you come here. All numerics will have no value. What has value is region, the string. Look at the way we are defining values. Here you click on here, you define value, and the value is defined the way you coded your variables, the way you coded them yourself. So we said 1, 0, a person lives away from Nairobi. So I come here. So 1 is Nairobi, living in Nairobi. Add. And then 0, elsewhere, just say elsewhere. Elsewhere. Because you ask them where they stay, they told you, me, I sleep in Nairobi, the others say I sleep elsewhere. I live elsewhere. And then done. Forget about the spelling, they are here, you can spell check. If I want to remove anything, I remove. If I want anything, I add. If I just want to change this one, I just come here and type over it. The same thing you do elsewhere. Then I do OK. Then I go to sex, gender. 1 is equal to female. Add. 0, the way you coded them is male. Add. And then now you go here. Where is that? Where is that one there? Whatever, here. And they're here. Gender, 1 is male, 0 is female. Union membership is here. 1 is union member, 0 is non-union member. Then I come here. Union membership. Then it's okay. Union membership is here. Here. 1 is a member. Add. 0, non-member. Non-member. And add. etc, etc for the rest. For all strings. Then missing. Look at the way I'm dealing with missing. You want missing for everything, isn't it? You can only copy numeric on numeric. So I will copy this one here, and place it to any other numeric. So even those ones, I'll just put 999. I just put, where is another numeric? It is this one. I will look at another one. If I want it also to use it also for string, I can't just put it here. You see, because these are different things. I must define it for strings also. I come here and I do 999. Yeah, sorry, 999. That. Then I can copy it on other strings. Other strings. Other strings. If strings are together, I just highlight like this and copy onto them. Come on, please. Highlight them like this and copy everywhere. Hey, come on, please. Also this thing. And copy everywhere for all strings. And then, of course, left line, forget about it. You see, all numeric, all non-numeric are nominal. You see, they are indicating nominal. Numeric ones are the ones you need to indicate a scale. Scale. Another one is scale. Another one is scale. Now, this is our structure, our Excel sheet, sorry, SPSS model for the data you have there. Then you come here, you can see these are your variables, just awaiting data entry. This way we would have entered 5,800 data items, units, which you don't have to. I simply come here. I'll just go back there. I'll go back to everyone. And I share this so that you see what I'm doing. Our concern now is data. We have defined our variables. This is the data. So I come here and copy all these things. They're the data set. Data, these are data items, everywhere. All the way to 534. Or if I saved it in Excel, I would just import from Excel. But I want to copy it from Word, where it is. where it is, and paste it that side. Eh? Paste it that side. Where is it? Come. Anyway, I'll go to the end. Let's go to the end. To the end. And then, of course, shift to the end. Then I copy. Copied. Then I come back to SPSS. And I share. Shared? You see that?
Yes.
Then copy, then paste. Perfectly pasted. It pasted, eh? Yeah. Paste. There you are. Let us get pasted, isn't it? 534 of them. Eh? If you want beauty, you come this side. Are you seeing this one? Yeah, alignment, eh? Yeah, you can come and if you want them center, I don't know why you'd want to do that anyway. It doesn't change your life, eh? It doesn't, eh? Just leave them this way. Eh? You can center them, you can left align them, right align them, whatever, but leave them this way. There's no problem. So now you have entered your data, waiting for analysis, for you to analyze the data. You see this, eh?
Yeah.
So that from there now, you can do many things here, many other things. You can now start doing transformation. You can then, after transforming, you can now, because analysis starts from here, going ahead, eh? You can now do transformation, analyze, graph, these three only, and you are done. Together?
Yeah.
Anybody with a challenge? So now, quickly. So if I wanted to analyze my data, forget about transformation first. And I want just to know the number of females in this population. The number of union members are in this population alone, or the number of males who are union members, the number of females who are union members. I come here. And those are frequencies. So I come here and I get my frequencies. Frequency only for the nominals. Then I come here and I look for only these ones here. How many union membership are here? How many females are here? How many, where is the other nominal? Union members are here. Where is the other one? Religious affiliation, which we have defined. We have not defined it yet. Eh? Occupation, sector, all of these things. Then you just bring them here. Then now you calculate. In fact, the ones we have done are these ones, just these two. These two. I think there were three. I remove this. Those ones we have not done. This is what I want to analyze. The frequency of the people appearing here. Then I check their statistics. I want statistics. What I want, I just want their frequency. There's nothing I need here. Just the number. So I don't have to take anything here. You cannot calculate the mean of gender. So you don't take anything here. Then I come this side. If I want a graph, I need a graph. I can get some graph here, like a bar chart here. But it's better to draw graph from here. But I want a bar chart here. Then I do okay. Sorry, I do come here. And then frequencies, of course, is on. Need my frequencies here. Then you come here. Then you do that. Then you have gotten your descriptive statistics. Descriptive statistics, which comes here. Still running. Then you get your statistics here. Nairobi, how many living elsewhere? 378. How many are Nairobi? 156.
Excuse me, please display the output.
Not displayed yet, huh? Oh yeah, you get. So this is the output now. This just by one variable, eh? Region, male, non-member. You see that, eh? But your analysis, better analysis is not for you to get number of males only female. You want to know how many males are union members and females are union members. Then you can look at their salaries, eh? Their salaries later. That again, you get it from here. You come here and now do descriptives. Then now you do a cross tab. Now you don't just get a simple frequency. You cross tabulate variables. Eh? So you come here, pick gender. Where's gender? Pick gender here. You can put it anywhere. Yeah, where is it? Union membership. You can put union membership here. And then of course the other things like cells. You know, I just want to see numbers. Their frequencies. Eh? Then the others you probably don't need statistics. You don't need any chart. Let's just get basic things. Then you come here. You can now see. These are males who are non-member. Members are 68. These are females who are non-member. Members are 20 what? 20? 28. This is the number of non-members, the number of members, which are in the upper table. This is the number of males, the number of females, which are in the upper table individually. Those ones you saw up here. So that's the mode of analysis the process that you want to go through. But only after you have known to define your variable and variable table. Is that okay, please?
Yes, sir.
Yes, sir.
Good. So, because for me, this is important for me, actually. It's important for me. And for you, actually for you and me, We need to, because we need to, I want us to go through a process that I'm going to send you a very simple data set. Eh? Very simple. I'm going to reduce that data set. I don't even have to reduce it. You know the one I sent you for the group work, eh? For the group work, eh?
Yes.
And you use it as a group. I would want you to perform some very basic statistical analysis, eh? Very basic, eh? Okay. Then we'll also use it now in our hypothesis testing and regression. I think we have around 3 lectures to go, don't we? Around 3 lectures, eh?
Yeah. Yes, 3 lectures.
Oh, excluding the exam one, eh?
Yes. Yeah, we're on week 10.
Is so excluding exam, isn't it?
Yes.
But I would rather that because this is also what I did with the other group. I would rather that probably you can create a day for SPSS, eh? Because I want to go through that thing, eh? A day for SPSS, eh? Alone, eh? Outside those classes, eh? It doesn't have to be weekday. It doesn't have to be weekday, as far as I'm concerned, eh? Then we can now take you through the entire. I know some of you attended SPSS, I'm aware. But not all of you did, eh? So I want you to create a day, even if we take a day for 3 hours, just to go through all of these things, eh? Using your assignment, eh? So that when you are handing in, you are handing in with some knowledge that what you have done is correct. So that day you can create it on any day you choose. And then for me, I'll be available, eh? Any day you choose, I'll be available. For SPSS, based on the assignment I'll send you, eh? Then we can go through the basics, then you can now go and run your assignment. Is that okay? We leave that to the class rep, eh? The class president, eh? To agree with you, eh?
Yes, sir.
Okay.
And of course, it cannot be after next week. We can only do it latest next week, eh? So that you have an adequate time, eh? Is that okay?
Yeah.
Where's my brother? Where's the class rep? Where is he?
I'm here. Yes, sir.
Oh, good. Thanks a lot, my brother. Thanks a lot. You know, when you're not there, we get worried, eh? That's okay. This challenge.
Yeah.
Now, I've sent some of you, a few of you do not have your results, eh?
Yes.
Well, I know very few, actually very few, probably around four people, eh? do not have. 4.
Including myself.
The rest do not have. The rest do not have. The rest already have, eh?
Yes, we have.
And you understand that what is the way they are marked, eh?
Yeah, we've seen the breakdown.
Yeah, beautiful. But if you want the marking scheme, I have it, eh? I have it. I'll scan and send to you, eh? It's good. It's good for you, isn't it?
Yes, sir.
Yeah, I will send to you. But before you'll get yours today. I know where they are, eh? You'll get yours today, yeah? Your results, eh?
Okay.
To you individually today.
Where are you sending the results from?
Yeah?
Are you sending the results on email or on Blackboard?
On email. I
No,
think.
you are not. That's what I'm saying. You have not gotten. You have not gotten yours, eh? So
I haven't.
eh?
Oh, thank you.
It's via email, so you will get your email, eh? For those who have not gotten. So we stop there.
Yes.
Yes.
Awesome.
Yes.
Yes, sir. Thank you.
Thanks a
Thank
lot.
you.
Yeah. But I'll send you the SP, the table, the data, eh? Let me just reorganize it a bit, then I'll send it to you tonight, eh?
And also the video of today, please.
I will. Is
Thank
there
you.
any video missing now?
No.
Only this one, isn't it?
Yes.
Yes.
I will send it. Let me do it just now before I leave, eh? Then you'll get it.
Okay.
Okay.
Excuse me, Prof. This is Anthony.
Yes, Anthony.
I hope you got my exam, which I did a week after.
Yes, but you know,
Yes.
my brother. You know, exam is not just done. you know. I think let's talk outside this. Let's talk outside this thing.
All right.
You know, if you missed an exam on a sitting day, you know what happens? You do a special exam. Eh? But I know you are ill. You know, you just do the exam a week later and then you submit. You know, that one is also not. You know, you want like. I think let's talk as brothers. Eh? I'll advise you. I'll guide you, because you see, if you do that, then you'll have challenges. Eh? Challenges because of one, you are ill, weren't you?
Yes, I was in hospital.
Evidence you are ill, so you don't have to stress yourself. You know, there's university policy guiding these things. You don't have to stress yourself. You just relax. Actually, I would suggest very strongly that you ignore any other exam you did a week after the exam, because in the university can be very bad on you. But let's talk outside this. Let's talk outside here.
Okay.
Because it's personal between you and me, that we can deal with it. You just call me now, eh?
I will.
Yeah, please.
Thank you.
Thanks a lot. Yeah, you have signed in, eh?
Yes.
Yeah.
Yes, sir.
Okay, sign for me there, Catherine. Just sign there, eh? Catherine off. Catherine Jorog, eh? Just sign for, because I'll forget. She has requested for permission. Just write her name there, then I'll remember when I'm checking, eh?
Okay.
Yeah, Father. Thanks a lot. That's all.